Good afternoon slash morning slash whenever you happen to be watching this calculus class. Hope you're having a fantastic day. Today we're going to be talking about the mean value theorem, also known as the MVT. Mean value theorem. All right. Now, a lot of people can get lost in the explanation of what it is. So I'm going to start out just by saying this. When you're going for the mean value theorem, you're basically trying to figure out why. You're trying to find out a y value that's averaging out between all of your different y values of your function. And here's how we do it. You remember we're taking the area with all of our rectangles, right? So the area of a rectangle, I'm just going to do this up here for you so you can kind of see what we're going to do, is base times height, which in this case is base times your y values, right? This would be your height. Well, if we wanted to find the average y value, all we would have to do would be to divide by our base, right? And that would give us the y values we're trying to find. This is what the mean value theorem says. We're going to take 1 over our base, like dividing by our base, and multiply it by the area to come up with the average y values. So it's 1 over our base, this is how wide our rectangle is, times area, which we know is our integral. And that's what this formula right here says. The mean value theorem, the objective is to find the height of a rectangle given the base and area. So this is how we're going to do it. 1 divided by the base, and the base in this rectangle is b minus a. So 1 divided by the base times the area. And that should give us our y's, right? Here's another way to think about it. The average value of f of x is what we're trying to find. The mean value theorem is the average value of f of x, or the average value of y, is the height of the rectangle with base b minus a, and whose area equals the area under the graph of f of x between x of a and x equals b. So what it's saying is that the rectangle right here has the same area as everything underneath this curve, right? It's saying the area of this rectangle is the area that's underneath all of this curve, right? So you can kind of think of it like this. So basically what that means is that this area right here, that little blank spot in the rectangle, is going to be filled in with this area here. It means these two areas are the same. So again, just think of it as we're taking our area and dividing the base out to figure out the height. And if you can think of it like that, it becomes a pretty simple process. So again, anytime you hear the words mean value theorem, you're thinking about y values. So if f of x equals x squared, find the average value of f on the interval 1 to 3 and interpret the results geometrically. Alright, so here we go. Ready? This is the MVT, or average value of y. Alright, so it's 1, let me go up just a little bit here, it's 1 over b minus a. That's how we get our rectangle. So our b is 3 and our a is 1, right? So we've got 1 over b minus a times area. That's going to be the integral. And this is also your a and your b for your integral of 1 to 3 of my function x squared dx. Let's see what that's going to be. 3 minus 1 is 2, so this is 1/2 times the integral. And let's integrate this thing. This will be x cubed over 3. And that's evaluated from 1 to 3. Right? So that's going to be 1/2. And you've got 9 minus, what is that? 1/3. f of b minus f of a. Remember, plug 3 in, you get 9. Plug 1 in, you get a third. That's going to be 1/2, and convert that to thirds. That'll be 27 over 3, so 26 over 3. So that's going to be 13 over 3. Alright, now what this means is that 13 over 3 is the height of our rectangle, or the mean value, right? This is the height of the rectangle, also known as the mean value. When they say the rectangle, they're talking about this value right here. So let's look at what this means graphically, right? Pull this up here just a little bit. So let's figure out what this is going to be. We've got from 1 to 3. And what they're saying is that the area under this curve from 1 to 3 at some point is going to be the area of a rectangle in here. Now let's figure out where our x is at. We know that the height is 13 thirds, right? 13 thirds. What is that? I have no idea. What is that? 4.3? 4 1/3? 1, 2, 3, 4 1/3. 4 1/3. 4 1/3. So here's what this thing is going to look like. What that means is that the area under this rectangle is going to be the same thing as the area under the curve from 1 to 3. So if you want to know what x value we would use for this, it's pretty simple here. You just have to take your function y equals x squared, and you have your y value of 13 thirds. So solve for it. X is going to be plus or minus square root of 13 thirds. That's the x value of where this thing is at, and it's going to be somewheres in there. As far as now, this what I mean by this is what we would use if we wanted to use one rectangle and do like a Riemann sum kind of thing. That's where we would have it at. Okay, so again, I want to stress here that if you're finding the average value, you're finding the mean value, you're finding y's. Back up here, finding the mean value, you're finding y's. Mean or average value. Okay? But the process is pretty simple. The only thing we're adding is dividing by the base of the rectangle. So I want you to go through here. Number 2, good example. It says find the average value. I'm going to underline that. Anytime you see average, you know that average and mean are interchangeable, right? So I see average, I'm going to write MVT of f of x equals 3x squared minus 2x on the interval 1 to 4. And find all values of x on the interval for which the function equals its average value. So this is a two-parter. It says first I got to find the mean value on this interval, and then find all of the x in the interval for which the function equals its average value. So this is going to be a two-parter. Let's see what we get. First it says find the average value, so let's go ahead and take care of that. I'm going to write this out here. Average value, mean value theorem, it's 1 over b minus a, so 1 over 4 minus 1 times the integral, it's a really bad integral sign, from 1 to 4 of 3x squared minus 2x dx. Now just so you're remembering here, this guy, is your width of the rectangle. This guy is the area of your rectangle. Just kind of keep that in mind, all right? So 4 minus 1 is 3, so 1/3. And then we've got the integral from 1 to 4, so let's go ahead and integrate this thing. It'll be 3x cubed over 3, which is x cubed, minus 2x squared over 2, which is x squared, evaluated from 1 to 4, which is going to be 1/3. Plug this in, you get 4 times x cubed is 64, minus 4 squared is 16. So that's f of b minus f of a. 1 cubed minus 1, which is 1/3, and this will go away to being 0 here. 64 minus 16 is 48. 1/3 times 48. 16. All right. So my mean value theorem, or my mean value, my average value here is 16. And then they want to know all the x's where the function equals that. So where does the function equal that? Let me flip back over to the front here. See, what they're after is this point right here. And I came up with that by just plugging my value in. That's the square root of 13/3. Right? This is what they're after. It's where does the rectangle meet the function. So plug it in. Plug in 16 for y equals 3x squared minus 2x. Set it to 0 because I've got multiple powers of x. And this one's going to be interesting to factor. Multiplies to 3, so 3x and 3, or 3x and x rather. And then I need it to multiply to a 16, negative 16, and add to negative 2 after a positive 3, which would be 6. So minus 8 plus 2. Let's see if that works. 3x squared, 6x, negative 8x, which is your minus 2, negative 16. Good, it works. So your x value is going to be negative 2 and 8/3. Now negative 2 is outside of my interval, so I don't care about that. My x value is 8/3, so it's 8/3, comma 16. And your answer, you can write it either way as x equals 8/3 or just 8/3, comma 16. Alrighty, let's keep going. Cruising along. Find the area of the region bounded by the graph of this graph and all this other jazz right here. Okay, so I didn't see anywhere in this question where they're asking me about an average value or a mean value, so I'm not using a mean value theorem here. Okay. Well, let's draw a picture of that. That's a parabola. It looks like it's going right a few and up a few, so let's just draw a rough sketch of what it's going to look like. This is just to get me an idea of what I'm looking for. Right a few, up a few. It may not be exactly that. I really don't care. But what they're saying is it's bounded between this graph, right? Y equals 0, so this is the x-axis. X equals 0, so that means that your x goes from 0 to 2. There's your bounds, so from 0 to 2. It's wanting this area right here. Different way of asking for an integral. So you know this is going to be the integral from 0 to 2 of 2x squared minus 3x plus 2 dx, which is going to be 2x cubed over 3 minus 3x squared over 2 plus 2x evaluated from 0 to 2. Alright, so that's going to give me here, starting off if I do it at 2, 2 cubed is 8 times 2 is 16, so 16 over 3 minus 2 squared is 4 times 3 is 12 over 2 is 6, so minus 6 plus 4. That's f of b. Now minus f of a. 0. Well, that was easy. 0, 0, 0. So that's going to be what? This will be negative 2, so it'll be 16 thirds. And 2, so minus 6 thirds. This will give you negative 2. Right? Minus 2, rather. So change it to a fraction. And that's 10 thirds. Yay! Now, really quick refresher on calculator stuff. Let's punch it into calculator. So we're going to do, again, this is the math button. You're going to choose the option for f in int. And your function goes in right here. So I'm going to do it this way. It's going to be y, comma, x, comma, 0, comma, 2. And this y right here, this is your function. Okay? And remember, this is the bottom of the integral here, and the top of the integral here. Alright, so very, very quickly, math, and if you go down to, I think it's 9, yep, 9, f in int. I'm going to do the old way. The rest of you who have the new way, just do it, because it's easier. Type in your junk, 2x cubed minus 3x plus 2, comma, x, comma, 0, comma, 2. Wait, did I type that in right? Squared! Oh, junk, I typed in a cube. Well, that'll change things. Hey, 3 1/3. Which is 3.333 continued. Always go to 3 decimal places. We had a lot of people on the test not do that. Always go to 3 decimal places. Okay? Y'all have a good one.